Good morning, good afternoon, good evening, all good. Let us start uh, this question which I gave you in the last class. I strongly believe that you must have attempted this question, but let us now try together. We need to calculate four different Ks in each scenario. In first, we have a beta equity 0.75. Let me write the formula of Capm. K is equal to RF plus RM minus RF into beta equity. K is equal to risk free rate is 6%. Okay. RM is 13% minus 6. Beta equity is 0.75. So here comes your K. 13 minus 6 into 0.75 plus 6. It is 11.25%. It is 11.25%. Now listen. The first finding is if beta equity is less than 1, if beta equity is less than 1, it means that your investment is less riskier than the market. When beta equity is less than 1, it means your investment is less riskier than the market. When your investment is less riskier than the market, then you will demand the return lower than the market. So KE will always be lower than RM. This is the first finding. Whenever beta equity is less than 1, it has the interpretation that your investment is less riskier than the market. Obviously, when my investment is less riskier than the market, then I will demand the return lower than the market. And it is happening in question 1. Because your RM is 13% and you are asking your RM is 13%, means average return on a stock exchange is 13%, but we are asking only 11.25%. The reason is only one, that beta equity is less than 1, which means your investment is less risky than the market. Let's go for case 2, where beta equity is exactly equal to 1. K is equal to RF is 6%, RM is 13 minus 6, and we have beta equity 1. We have beta equity 1. Obviously, RF will be cancelled with RF, and your answer must be equal to 13%. Another question is why our answer is must be equal to 13%. Let me tell you something first mathematically. Oh, definitely, if I multiply this with 1, it's going to be like this. A is plus 13% minus 6%. This will be cancelled off. Logically, your answer is 13%. Now try to understand why do we have answer 13%. Whenever your beta equity is equal to 1, it means the risk of your investment is equal to the market risk. The risk of your investment is, let's say, equal to the risk of a stock index. Second finding, when beta equity is equal to 1, it has the interpretation. Interpretation of beta equity is equal to 1 means your investment is facing the same risk which the market is facing. Simply, in other words, the systematic risk of your investment is equal to the systematic risk of the market. Why did I mention systematic risk? Why not unsystematic risk? There's a reason. In capital asset pricing model, we always assume that investor is having a well diversified portfolio of investment, and whoever is having a well diversified portfolio of investment, that company does not face, that investor does not face unsystematic risk. So when investor is not facing unsystematic risk, then obviously we'll talk about only systematic risk. So let's come back to beta equity 1. Beta equity is equal to 1 means the risk of your investment is equal to the risk of market. When my investment is facing the same risk which is in the market, so definitely I will demand the return which is on average on the market, RM. So the second finding is whenever beta equity is equal to 1, your KE will always be equal to RM. Now let's go for third requirement. K is equal to RF is 6%. 13 minus 6, let me check what is beta equity. Dear student, in point number 3, the beta equity is 1.75. Okay. Let me multiply this with 1.75. Let me check what I'm getting. I'm getting 18.25%. Now you can see that right now investors, shareholders, they are demanding a return even more than the market return. Why it is happening? Let me discuss third finding. Whenever beta equity is going to be more than 1, whenever beta equity is going to be more than 1, it means that your investment is more riskier than the market. Repeat. Beta equity more than 1 is representing that your investment is more riskier than the market. When my investment is more riskier than the market, then obviously I will demand a return higher than the market. So whenever beta equity will be more than 1, your answer must be K must be more than RM. And it can be seen in this question number 3 that K is coming 18.25%. On the other end, RM is only 13%. So simply, whenever beta equity is more than 1, it has the interpretation that your investment is more risky than the market. When my investment is more risky than the market, so definitely I will demand the return more than the market. Case 4 and the last. K is equal to RF plus RM minus RF into beta equity. Let's check what is beta equity. In fourth requirement, beta equity is 0. Okay. Let me just write 0 here. This 0 will make all of this 0, which means KE is equal to 6%. Here comes the fourth and the last finding. Whenever beta equity is equal to 0, whenever beta equity is equal to 0, it means that you have made the investment which is risk free. Beta equity is equal to 0 means your investment is not facing any risk. Obviously, when your investment is not facing any risk, then you will demand the return. K will be equal to RF. K cannot be more than RF because your investment is not facing any risk. When my investment is not facing any risk, then I will simply demand the return equal to RF, risk-free rate of return. And beta equity 0 means you have made a risk-free investment. Let's say your company has invested in government bonds. So obviously you will demand the return. exactly equal to RF because you are not facing any risk. Okay, now dear student, try to understand one thing. What is that? Now I just want to say one thing. If we have the information of only beta equity, if we know the answer of beta equity in the question, then we can easily tell someone Ke will be equal to either Rm, either Ke will be equal to uh, Rf, or whether Ke will be more than Rm or less than Rf, or less than Rm. Ke cannot be less than Rf, obviously. So if we just know beta equity, we can easily tell the results. If beta equity is less than 1, your Ke will be less than Rm. If beta equity is equal to 1, your Ke will be equal to Rm. If beta equity is more than 1, your Ke will be more than Rm. If beta equity is 0, your Ke will be equal to Rf. Okay, now let's go to another model for calculating Ke. We have discussed DVM, dividend valuation model. We have discussed Capm, capital asset pricing model. Now let us discuss DVM, dividend valuation model. We do call it dividend growth model as well. Let me repeat, dividend valuation model or dividend growth model. This is another way of calculating KE, is dividend valuation model. Let me write the formula. KE is equal to D naught 1 plus G divided by P naught plus G. That's the formula of dividend valuation model or dividend growth model. KE is equal to D naught 1 plus G divided by P naught plus G. KE, obviously we know that. KE is cost of equity. Obviously it is cost for the organization, but for shareholders it is a return. Minimum return required by the shareholders. D naught, that is current dividend per share. Current dividend per share. G is annual dividend growth rate. Annual dividend growth rate. And in dividend valuation model, we always assume that annual dividend growth rate is constant. Repeat. In dividend valuation model, we always assume that annual dividend growth rate is constant. So we always work on this assumption that annual dividend growth rate is constant. Okay. D naught into 1 plus G is actually equal to D1. D1 means next year expected dividend. D1 means next year expected dividend. Okay. P naught, that is current share price. Current share price, but X dividend. X div. P naught is current share price, which is X div. X div means excluding the effect of dividend. X div means excluding the effect of dividend. There's one more price. The name of that price is cum div. CUM. Cum div means including dividend, cumulative of dividend. Cum div price means cumulative of dividend, which has the impact of dividend. But in dividend valuation model, we always take X div values. Now the question is, if nothing is mentioned in the question, then that price is always assumed as X div. For cum div price, examiner will categorically write in the question that this given price is a cum div price. So simply nothing is mentioned, always assume that given price is X div. For cum div, examiner will write it down. Now another question. Why do we use X div current share price in dividend valuation model? Why we are not using cum div? Why we are using X div? Let me give you the reason of this using X div current share price in dividend valuation model. Actually, we are calculating KE, which will be used in cost of capital. And objective of cost of capital is investment appraisal. And dear student, investment appraisal is a long-term decision, it's not a short-term decision. So why do we use X div share price? Basically, I'm going to calculate KE, and that KE is a part of cost of capital, and cost of capital is objective of cost of capital is investment appraisal, which is a long-term decision. So since at the end of the day I'm going to make a long-term decision, so I'm not supposed to use cum div values, because cum div values do not exist throughout the year on a stock exchange, at a stock exchange. But on the other hand, X div values, they do exist throughout the year at stock exchange. So try not to use cum div value in calculating KE, because this value does not exist throughout the year. And we need to use cost of capital for investment appraisal, which is a long-term decision. So we should not be using any input like cum div, which does not exist throughout the year. Okay, now let's see a question. Current share price is $20. Annual dividend growth rate is 6%. Current dividend per share is $2. We just need to calculate KE. Current share price is $20. Annual dividend growth rate is 6%. Current dividend per share is $2. Since nothing is mentioned, it is always assumed that given share price is X div. Current dividend is 2 into 1.06 divided by 20 plus 0.06. Let me use a calculator. Oh, 1.06 K is coming 16.6%. Let me try again. 2 into 1.06. Yes, K is 16.6%. Perfect. Second question. Current share price is 25. Cum div. Current dividend. Current dividend per share is $5. Annual dividend growth rate is 10%. Current share price is 25, which is written cum div. Cum div means cumulative of dividend. Current dividend per share is $5. Annual dividend growth rate is 10%. We need to calculate K. T naught is 5, 1.1. Now I need to multiply this with P naught, but I will not take cum div. Cum div means cumulative of dividend. We have to make it ex div, excluding dividend. So the cum div price is 25 and the dividend is 5. If I deduct the dividend, I will get ex div price $20. Repeat. Cum div price is 25. Cum div means cumulative of dividend. And current dividend per share is $5. If I deduct $5, which I have to, from 25 cum div price, I'll get the ex div price, which is 20. So let me use the calculator. Mhm. Let me check. 5 into 1.1. K is coming 37.5%. Actually, whatever answer is coming actually 0.375, but you have to multiply this with 100. So you will get K 37.5%. Very healthy, I would say. Question 3. Dividend per share is 0.4 in 2018. Dividend per share is 0.6 in 2000. Dividend per share is 7. Dividend per share is, let's say, 0.9. So we have dividend per share 0.4 in 2018. We have dividend per share 0.6 in 2019. Then we have 0.7. Then we have 0.9. Current share price is 20.9. Cum div. Okay. Required is calculate K. Current share price is 20.9, which is cum div. Cum div means including dividend. Now, first point. The last year of the question is the current year, which is 2021. Last year of the question is the current year, which is 2021. Okay. In this question, we do have a current share price 20.9 cum div. If I deduct 0.9 from the cum div, I'll get the current share price 20. Okay. But only one thing is missing in this question. and that is annual dividend growth rate. If I can manage to calculate annual dividend growth rate, then seriously, after calculating dividend growth rate, there's nothing in this question. So how do we calculate annual dividend growth rate? Now listen carefully. In dividend valuation model, we always assume that dividend growth rate is constant. So whenever you have been given an information like this, you have to use a formula for the growth rate, which is G is equal to n minus 1 last dividend per share. Divide this with first dividend per share minus 1. This minus 1 is outside this square root sign, or you can say radical sign. In a really good maths, this sign is called radical sign. Otherwise, we call it the square root. Okay, G is equal to n minus 1. Then within that radical sign, last dividend per share divided by first dividend per share. Then outside this radical sign is minus 1. N is of course number of years. The same formula can also be written like this. Last dividend per share divided by first dividend 1 upon n minus 1 into this. Now let's apply. We have 4 years. 1, 2, 3, 4. Then while calculating annual dividend growth rate, growth n is going to be 4 minus 1, n will become 3. So the last dividend is 0.9. So we have been given fourth year, or total number of years 4, but power is going to be 3. Let me use the calculator. 0.9 divided by 0.5. Okay. Growth rate is coming 31%. Please, dear student, you people also check. 0.9 I divided with 0.4 to the power. Yes, dear student, the answer is 31%. Now I can easily calculate KE from dividend valuation model. D naught is 0.9 into 1.31, and current share price is 20.9 come diff. So X div is going to be 20. So let's use the calculator. 0.9 into 1.31. So 0.9 into 1.31. So dear student, I'm getting the answer 36.87 or 37%. Please, you people also check. If you find any arithmetical error, then please correct it. 0.9 into 1.31. So I'm getting 36.8 something. So I've just rounded off. After rounding off, the K is coming 37%. Now let me tell you one more thing. We have one formula. The name of that formula is Gordon growth model. Gordon growth model. Sometimes we use Gordon growth model to calculate annual dividend growth rate. Repeat. Sometimes what do? We use Gordon growth model to calculate annual dividend growth rate. The Gordon growth model is having a formula G is equal to BRE. The formula of the Gordon growth model is G is equal to BRE. G is of course annual dividend growth rate. Annual dividend growth rate, which we assume constant. Now what is this B? B is actually a retention ratio. Retention ratio. B is a retention ratio. Now, dear students, try to understand what do you mean by retention ratio. Listen, if your company is distributing 40% as dividend, if your company is distributing 40% as dividend, then we'll say the retention percentage is 60. If any company is distributing 25%, then I will say the retention is 75%. If your examiner says your company is paying 30% dividend, so it means you are retaining 70%. So how do we calculate B? 1 minus payout ratio. Obviously, after deducting a payout ratio, you will get the retention ratio. B is equal to 1 minus payout ratio. Now the question is, how do we calculate payout ratio? Payout ratio is D naught upon EPS. Very logical. Basically, D naught is current dividend per share divided by earning per share. Obviously, the payout ratio, from where do we pay? We pay from earnings. So how do we calculate payout ratio? D naught upon EPS, earning per share. Okay. Now in the formula we have RE. Now the question is, what is this RE? RE is return on equity. How do we calculate RE, return on equity? This is actually equal to profit after tax divided by total equity. Actually, how do we calculate RE? RE is return on equity, and return on equity is equal to profit after tax divided by total equity in 100. Now, dear student, try to understand very important point. RE is return on equity. We calculate RE like this. These things actually we use in F9. Obviously, in F9 we say RE is return on equity. How do we calculate return on equity? We calculate return on equity but simply by dividing profit after tax with total equity. But in AFM, previously we called it P4, and if I go further back, we used to call it 3.7. That's the very old name of this paper. Before 3.7, I have no idea. So the latest name is AFM. The previous was P4, and the name before P4 was 3.7. Okay, leave that. Now, in AFM, and obviously in previously P4 and previously 3.7. Gordon growth model is little bit different. In AFM, we say the Gordon growth model is G is equal to B K. This is the Gordon growth model which we will be using in AFM. So in AFM, your growth rate in Gordon growth model G is equal to B into KE. KE obviously cost of equity. So in Gordon growth model, what do we do? We calculate G. How do we calculate G? G is equal to B. B is same, but this time we multiply B with KE. So in AFM, just little change. Gordon growth model will be like this: G is equal to B KE. K is cost of equity. Let me give you a question. I have RF 6%, RM 15. I have a beta equity 1.75. Okay. Dividend per share is 0.4 in 2020. Dividend per share is 0.6 in 2020. We have dividend per share 0.4, 0.6. We have RF, RM, and we have KE as well. Okay. The requirement is P naught, current share price. RF is equal to 6%. RM is equal to 15%. Beta equity is equal to 1.75. Dividend per share is 0.4 in 2020, and dividend per share is 0.6 in 2021. And this time I need P naught. Okay, I would say this a small question, and that small question is your homework. HW. Dear students, I want every one of you to attempt this question, and I really want you to try to calculate P naught. And the next class, inshallah, we'll start from this question, and then obviously you will be able to see the answer. But I really want, dear students, every one of you must try to attempt this question. Thank you very much for watching this lecture. Have a nice life. Thanks a lot.